Right. So in this video, we are going to learn about how to use a commercial finite element analysis software package. Regardless which package you're going to be using, there are three main steps that you are going to be working on or have to undergo in order to run an analysis. The first step is known as the pre-process, followed by the process itself, and then the data process. So you can see that the first step is done by the user, the second is the computer, and the third step is also by user. What does that entails? In a pre-process, we are really building the finite element model. So we need five things. We need to define the geometry, which usually is going to come from a CAD. We're going to need to assign a material. So at least we need the modulus of elasticity. And most software packages are also going to require Poisson's ratio because they work in 3D. We are going to discretize or create a mesh. Almost every commercial software package has an auto mesher or mesh generator. Next, we're going to prepare the model for the analysis we want to perform. And this is going to entail two things: to define the constraints or the boundary conditions for a structure analysis, that would be the supports. And next is to apply the loads. So this is what we're going to be doing in the pre-process. Once this is complete, I can run the engine or run the solution where the computer is going to conduct the numerical analysis for me. Once I have a solution ready, it is going to be time to look at results. And this is the post-process, where we are going to need to define results, what we are really trying to find or interested in. We are going to display these results and evaluate to find what we are interested in. And it is important to note that these steps are true regardless of which software package you're going to be using. Here, we would like to learn to use ANSYS Workbench. So I would like to also show the steps that we are going to be taking as we use ANSYS Workbench. So first, let me mention that ANSYS Workbench was introduced about almost in 2009. And the idea of Workbench is to create a project management and data management platform. From this platform, we can share data between different types of analysis, material data, geometry, and manage our project. So when we want to perform a static structure analysis from Workbench, we are going to be using really three platforms. First one is Workbench. The next, we're going to be using in this course, we're going to be using Design Modeler to create or edit a CAD. And we are going to be using ANSYS Mechanical to run a static structure analysis. So you're going to be seeing these three platforms or three interfaces that you're going to be working with. So I created and put together here a table to show you which platform is going to be used for what. So in Workbench, you are going to define or create an analysis system. For our purposes, that's going to be a static structural analysis system. So we're going to be doing that in ANSYS Workbench. Within Workbench, we are also able to define our engineering data. Primarily here, we are going to define the material properties that we're going to be using within the model. Next is going to be the geometry. And these steps are going to be identical 1 through 7. You're going to see that in the analysis system for static structural analysis. For the geometry, you have two options. You can import a geometry or a CAD file from within Workbench, or you can use one of the ANSYS CAD packages to create a geometry. In this course, we're going to be using Design Modeler. From within Design Modeler, we can create one-dimensional, two-dimensional, or three-dimensional geometry. If you also import the geometry, you can do some edits within Design Modeler. Step number 4 is going to be the model. We have defined a material, or even maybe multiple materials, but these materials are not yet assigned to your parts or components. So you may have an assembly and you may have parts made of different material. So the first step you want to do when you launch mechanical, so now we're moving to the third platform, is to assign the material to the geometry or the model or the part or the component. Next, we are going to generate the mesh. This is all still within ANSYS Mechanical. So you can use the auto mesher, you can refine the mesh as needed from ANSYS Mechanical. Next comes the setup of the model. This is where we define the constraints or the supports, and we get to apply the loads. This is loads. Okay. And step number 6, that would be just a click of a button to run the solver or start the process to see whether we have a good model and have a solution or not. In each of these steps, you're going to get a feedback in terms of icons. A green check mark indicates that this step has been completed. If you get a red icon, there is a problem or there is a warning. You may get a yellow, like a flash icon, meaning that this is work in progress or not yet completed. And we're going to see that when we work with ANSYS shortly. Finally, you get to the results. And for the results, after having a solution, you need to define results, what you're interested in. Could be support reactions, could be deflection, could be a strain, could be of a mesostress, you name it. We're going to learn how to define that. And then we're going to examine these results to make sure that they make sense to us. One of the very important things we want to do always when we run a commercial software package is to make sure that our model is capturing the behavior that we expect. So always we want to look at this animation that shows how a part deform, for example, before evaluating the rest of the results. You can then move forward to look at other things you may be interested in. So let me do a quick walk through ANSYS Workbench to show these things that I have just described. So when you launch ANSYS Workbench, that's what you're going to be seeing. So we have the typical pull-down menu, file, view, tool, units, and so on. We have our toolbar menu, and you please note that we have the project tab right now open. I have a project schematic that really takes most of the area of the screen. And to the left, we have toolbox. And you see under toolbox, I have an analysis systems, component systems, custom system, design exploration, and so on. I would like to focus today on a couple of things, analysis systems and component systems. So if I click analysis systems, this is going to see you the different types of analysis that we can perform from within Workbench. So you could run an explicit dynamics, a fluid flow, you can run LS Dyna, you can run a model analysis, model acoustic, static structure, steady state thermal. And some of these systems can have results that feed into other systems. So, for example, I can run a steady thermal analysis and then use the temperature distribution as an input to a static structure analysis to calculate stresses in the part due to these temperature variation. I'm going to start here by showing an example. So if, for example, if I double click a steady state thermal analysis, this is going to create the system, and there are 7 steps for the steady state thermal analysis. And you will notice that there are components. So there is the engineering data that gets defined from Workbench. There is a geometry, there is a model, there is a setup, there is solution, the results, the 7 steps that we discussed. Now, one of the components here we have is the geometry. If I go to component systems, you see that I can create components rather than an analysis system. And one of the components could be a geometry. So I can create a geometry. And I may use this geometry to feed into a static analysis or even a steady state thermal analysis. So I can come here and use that geometry to feed into my steady state thermal. That's why we say it is data management. Once I have the data, I can use this data for a steady state thermal. I can use the data for a static structure analysis as well. So I can come here and go to static structure and create a static structure that uses the same geometry. Maybe I want to create a static structure analysis that uses the solution of my steady state thermal. So it shares the engineering data, the geometry, and the model, and use the solution as an input to a static structure analysis. So this is why we say that Workbench is for project management and data management. So multiple teams could be working on the same project in Workbench, each doing their part, and we can all share the data and see where we're at with the project. If I am running a static structure analysis, if I double click on engineering data, that would open a new tab and get me to use some of the engineering data sources that are available, or I can define my own material. So this is where we get to define material. I can come click here and add a material. For example, I add testing material. And once I add a material, I need to choose from the toolbox what kind of behavior do I expect from this behavior. So if I come here and I pick like linear elastic and I choose isotropic elasticity, then I need to input the material property. And you see, at least I need to put a Young's modulus and a Poisson's ratio. I can toggle back and forth between engineering data and the project. When it comes to the geometry, I can do a right click and create a new geometry, or I can import a geometry. So it looks like this is not enabled here, but I should be able to create a geometry, import a geometry from a CATIA, from a Creo, from SolidWorks, a step file, IGES, you name it. For the model itself, if you double click on model, this, as you can read here, it says starting mechanical. So this is going to launch another interface, which is ANSYS mechanical. Sorry, my computer is a bit slow. It really shouldn't take that long. I wonder if this is going to crash or does not have a proper license setup. Something does not look right here. Okay, here it comes. It shouldn't really take that long. But this is the ANSYS mechanical interface. Right. So automatically you're gonna get, if I create the geometry, I'm gonna see my geometry here. Obviously my geometry is not yet completed. I'm gonna see my materials. I get to assign my material to the geometry, create the mesh. For a static structure analysis, we are gonna have to define the supports, apply the loads, and then run the solution. Once I have a solution, I can start defining results like deformation, strain, stress, energy, and so on. So this is a general idea about the steps that we are going to undertake within ANSYS to perform a static structure analysis. Again, there are 7 steps. The first step, we're going to define the analysis system. 2, we're going to define the material. 3, we're going to create the geometry. 5, we're going to set up the analysis by defining the constraints and applying the loads. 6, we're going to run the solution. And 7, we are going to define the results and look at the results.